So, hello everybody. The paper is entitled Examining Accuracy Heterogeneities in the Classification of Multilingual AI Generated Text. And so the main objective that came with this study was studying the differences in how AI detection, that is, detection of AI generated text, the failures, as well as the successes, although we observed that the failures were more common than the successes, appear across languages when attempted on human-written and AI-generated text. We say across languages, we're referring to not only the high-resource languages, such as the Western European or English languages. We wanted to look at lower resource languages as well as Swahili, such as Hindi, and other such languages. And the types, the specific context in which we wanted to investigate this is we wanted to see how problems in AI detection would manifest itself specifically and primarily in the schooling systems. And when I'm talking about schooling systems, I'm referring to both higher education as well as K-12 education, especially as these large language models, such as ChatGPT and these generative AI models, how they're becoming easier and easier to use in daily tasks, whether that be assignments and whether that be essays, all of these opportunities for AI generated text to possibly go unnoticed. We wanted to make sure that that doesn't occur, because obviously if we have university students going 4+ years through their education, not actually completing work on their own or not being educated, which is the purpose of why they're going there, we have a workforce, or if they go to academia, we have researchers that are not proficient in the fields that they possibly have claimed to study when they were actually using these generative AI tools. And of course, that's something that we want to prevent. And we also see that problem in possibly in research and in the workforce, both academia and professional applications. And although there has not been large studies on how prevalent this is, because there are many complications in attempting these self-reporting models in which we ask people to admit when they've done these things, because there's not always a high level of honesty. It still is an opportunity for these generative AI tools to be used in these high-level opportunities, whether it's assignments, whether it's research, whether it's more important work too. And so we just wanted to see how AI detection could help and why it's not at the current state it needs to be in terms of accuracy. And so I'd like to touch upon two specific instances. They're very brief instances that I'll talk about. There were 3 Asian languages that were initially studied, not by us, by another group of researchers, and they were all human-written, fully human-written. There was no AI involved. And they were given to 3 different AI text detection services. And interestingly, out of these 3 languages, out of all 3 of them, which are not as high resource in nature as English, although we could say that Malay is one of the most low resource languages out of those 3. All 3 of them are generally, they are not as highly used in the NLP landscape as English is, of course. But when we look at these 3 languages, then all 3 of those AI text detection services were used on human-written text by humans in these 3 languages. They were all marked as AI generated, and they were flagged as such. And that's important to know because, of course, these generative AI models are not only being used in English-dominant countries, and when used internationally, especially in these Asian, Southeast Asian, East Asian countries, it's maybe a problem when human-written text is given to these AI detection modules. And often we see plagiarism checks across the board in many fields, whether it's schooling, whether it's academia, whether it's jobs even. But when these plagiarism tools, and now these plagiarism tools are starting to incorporate AI detection in them, when they incorrectly mark, in fact, human-written text as being AI generated, when they were in fact written by humans, that can be dangerous for people that are actually genuinely putting their work out there and falsely being accused of using AI or using generative AI when in fact they're doing it themselves. That can be quite problematic. But interestingly enough, when we look at the other side, when we look at English, there was a specific case in which essays in English, were completed and they all received first class rankings in an accredited university's physics module. And this was done in the UK. All these essays were very high scoring, and first class essentially is the highest that you could earn in that university. When they were given to a few AI detection services, interesting results came to that. When it was given to Turnitin.com, which is a common plagiarism tool, it's been used for a couple of years, and now among the rise of AI, there's AI detection tools incorporated into this plagiarism checkers. It only received a rank of 7% likely to be AI generated. And when you look at Grammarly.com, which I'm sure is quite popular, it used to be just purely for grammar checking and autocorrect. However, when their AI detection service had these essays reviewed, there was only 2% likely AI generated. That was the flag that was given. So we see two distinct sides to this, where certain languages, they're having a high rate of false positives and that they're being flagged as AI when they're in fact not. And we also have false negatives on the side of English, in that these English essays were being marked as being human written when they were fully AI generated. And so we went in with this notion that this may be the general trend that we might see with other languages as well, but we want to see the specifics of how this would manifest in these 6 languages that we picked. And so the AI text classifier, that's the specific tool that we used. And so this AI text classifier, it's made by the company OpenAI. It was made public. And they're the parent company of the ChatGPT, which is a very popular generative AI model. And it's one of the most commonly used by the public. I'd say it is one of the most popularly used. And for that reason, we wanted to pick this specific AI text classifier as opposed to, say, Turnitin.com or Grammarly.com, or this myriad of many, many different AI text detection services, because we would assume that OpenAI would presumably have the most training data that was based on ChatGPT itself, the responses from ChatGPT. And so since we were looking at the cheating context in schooling, academia, etc., we assumed that this would be the best tool for this. And so we specifically tested this detection model. And the responses that come when you put text into this, you can get 1 of 5 different responses, which is, it initially follows the format. The classifier considers the text to be blank AI generated, and it can be either ranked possibly AI generated, it can be unlikely AI generated, very unlikely generated, or likely AI generated. And there's also a 5th one that is UC, or unclear. And that's an interesting one because it occurs when there is no confidence on either side, which is it cannot differentiate whether it's likely or whether it's unlikely. And so we saw a few interesting results from that UC category as well. And the languages that we selected 6 languages. We selected languages with fairly large populations of speakers from across the globe. We didn't want to stick to just European languages or Indo-European languages, nor Asiatic languages, because we didn't want to see that same trend that we're seeing with purely Western European languages being studied, or just certain cherry-picked languages from across the globe. We wanted to see how it performed on a wider set. So we took high research languages such as English, German to an extent, but then we also had low research languages such as Hindi, such as Swahili, and we also had these languages with large population speakers, Arabic, and simplified Chinese. We wanted to see how these languages would get responses from the AI text classifier. And when we did do this, we took the GPT 3.5 model, and we actually asked, write a story / article / poem / argumentative piece about topic and position, if applicable, in 1,200 characters. And so what we did is we picked one of these 4 topics, and we would ask for 1,200 characters specifically, because we wanted the AI text classifier to have as much accuracy as possible. And it's actually stated on the OpenAI website for that AI text classifier that with the larger the input, the higher the accuracy. And there was actually also a limit for the characters, a lower limit, as in you need to be above that, or else it wouldn't be able to classify whether it was likely, unlikely, or unclear whether it was AI generated. So those specific topics that we used were, we picked 4. We picked story, poem, informational article, argumentative piece, and we did this because we wanted some of the more common, more informational pieces, which did not require creativity, but required more of either argumentation or just facts, and that would be informational article and argumentative piece. But we also wanted to look at more creative pieces of writing, such as stories and such as poems. And so what we did for each of these topics is that we would generate text in AI, with GPT 3.5 model for each of these. But for each of them, we would also go to the Internet Archive and Project Gutenberg. And those are both large sources for human written text. And we use these databases for each AI generated piece of text in either story, informational article, poem, and argumentative piece in each of the 6 languages that we said, which were English, German, Chinese, Swahili, Arabic. And these languages, what we would do is we would pull for each AI generated text, we would have a corresponding one that would be human written from these 2 sources, Project Gutenberg and Internet Archive, as I stated previously. And so what this would do is we created a large text corpus with combined both human written text, and there would be a text that would have the same topic and the same position, if applicable. For instance, argumentative piece, that's when we would ask it to have a position as well. And what we would do is we would have something corresponding to that in AI generated text, and then we would put both of those into the AI Text Classifier tool from OpenAI. And something we saw, these are some of the results that we saw with the labelings. And so as we put those 100-something texts into the AI Text Classifier, we saw for each language how this translated into the labelings. And so as previously mentioned, P would correspond to possibly AI generated labeling. UL would correspond to unlikely to be AI generated. L would be likely to be AI generated. VU would be very unlikely to be AI generated. And then UC is the unclear rating that we talk about. And interestingly, when we look at the likely and the possibly ratings, the overwhelming majority of them came from 2 languages, which is Hindi and Arabic. And as we see, they accounted for a total combined 70% of the possibly ratings. And Arabic in specific accounted for 88% of the likely labelings. And that is notable because these rankings, labelings, are based on the combined corpus of both human-generated text and AI-generated text. So that would mean that these likely and these possibly labelings would most probably mean that even text that was human written would be incorrectly marked as AI generated when in fact was written by a human. And that might be why we're seeing such a large percentage of these likely or these possibly labelings coming from 2 languages in specific. On the flip side, when we look at unlikely and very unlikely, we see that English accounts for the majority of the very unlikely labelings. And when we look at unlikely, it's also English that has about 41%. And this fairly corresponds to the other physics example that we saw in UK universities, where English essays, they were marked, even if they were AI generated, they were marked as human written. And so that might be what we're seeing here as well. And that's what we initially inferred, is that because so many of these English texts were being ranked as unlikely or very unlikely, that possibly many of these were being mislabeled when they were actually AI generated. And interestingly, when we look at these 3 languages of Swahili, German, and Chinese, and we specifically use simplified Chinese, and since we're doing text-based, that's important to specify. It's not traditional. But when we look at UC labelings, which is the unclear, Swahili, German, and Chinese, they accounted for a combined 80+% of these unclear labelings. And that is interesting how the AI text classifier has a certain level of confidence with Hindi and Arabic, along with English. However, it does not seem to have much confidence in the labeling Swahili, German, Chinese as either likely to be AI generated or unlikely to be AI generated. And so it's just does not have enough confidence to label it on either side of the spectrum. And we thought that was quite notable, as we saw, which we would expect it, at least Chinese, to have some level of confidence, as we saw in the initial study by Wei and Reimer, how Chinese was marked as consistently as AI generated when in fact was human written. But here we can see that it manifests itself slightly differently in that many of them are just marked as unclear. And we also distributed this by a number of false positives and false negatives. And when we say false positives, again, it means that positive referring to AI generated, if it was human written, a false positive would be labeling it incorrectly as AI generated. And for false negatives, it would be when a text is in fact AI generated, it would be incorrectly marked as human written. And we see for false negatives, English has the overwhelming majority, it accounts for 88% of the total false negatives. And this is unique because it also corresponds to the OpenAI disclaimer on its website that the OpenAI text classifier, it only classifies text as AI generated. It has a very high confidence. That is, it has a very high threshold for this. And if it isn't completely confident that something is AI generated, then it will mark it as human written. And so that's standard. Interestingly, it manifests itself in English. However, we do not see that pattern in the other languages, in Hindi, Arabic, Swahili, German, Chinese. We see that pattern of being marked as human written when there's low confidence, that does not manifest itself, as we see almost no false negatives reported in the Hindi, Arabic, Swahili, German, Chinese categories. However, for false positives, we do see many false positives, 80% plus from Hindi and Arabic. And as we saw in that previous slide, how Hindi and Arabic had many of those likely and possibly AI-generated labelings, they also have a large percentage of false positives as well. And so many of them, even though they were in fact created by humans, they're incorrectly being marked again and again. And with the UC labelings, the unclear labelings, we saw that Swahili, German, and Chinese, again, they correspond with that UC labeling inference that the model just isn't confident whether it's likely or unlikely to be AI generated. And so as we can see, there's a large level of variability in this. And so we sought to find some sort of pattern, possibly with language families or with a region of the world or some sort. But there was not that much of a correspondence. There was, we grouped it somewhat in that Hindi and Arabic, they seem to be these Asian languages that consistently were being marked incorrectly as being AI generated when they were written by a human. We have English, of course, and English was the one that is consistently, since the disclaimer that we are not, when I say we, I'm referring to the AI text classifier, the disclaimer that they are not going to label any text as AI generated unless they have a very high confidence. And therefore the majority of English was either correctly or incorrectly marked as human written. But then these UC labelings are also very unique, as we see that all these three languages, even though they are widely used languages, there is not much confidence. And when we say that, it's also notable that it can probably not be argued that that Chinese, Swahili, and German, all three are more high resource than Hindi and Arabic, for example. But it's interesting how these languages in specific were consistently marked as unclear, and there wasn't able to be confident predictions from this. Another thing to note is that when we did this, we did set the limit as 1,200 characters. But it's important to note that with languages such as Arabic, for example, Arabic, for each word, it has an average character like character of five characters per word. However, all languages might not be like that. For example, Chinese, it only has two characters per word is the average. And on top of that, Chinese does not use spaces very much. So we can clearly see how words may increase in certain languages. There may be, say, 500, for example, in one language, whereas there might be only 300 in another language. And all of these numbers are not correctly corresponding to the characters, but that's just an example of how the word length might differ in each of these languages. And that is notable because, as we saw with the AI text classifier, as you get longer input, it gives you more confidence. But somehow we also see the opposite trend here in that Arabic, if it were to have less compared to Chinese, since it has longer characters of words, somehow that has more confidence in the prediction than Chinese, which would have more words than Arabic. But for some reason, it's consistently being marked as unclear. And so you can see how there's somewhat of an unpredictable nature that's demonstrated in these AI text classifiers. And that's something that we see actually from OpenAI site itself. And this was actually something unique that I was surprised to hear, is that a few weeks after completing this experiment, and this past week, actually, a few days ago, they shut down this AI text classifier because of its high rates of inaccuracy. And I found that very interesting because instead of specifically focusing on developing and researching this text detection, they've also made a commitment on their site of contributing more to detection of audio and visual content that is AI generated. And so I think some things we may be able to predict as this plays out in the following months is there is a possibility that maybe this detection of AI generated text, possibly there is not going to be further research and development, and more research is going to be purely devoted to these audio and visual outputs. Or another possibility is that it has just become, I'm saying the generative AI model itself is becoming so well developed that it's becoming more and more difficult to detect it at all. So possibly the research is being done, but there's not being tangible results on how we can detect when these texts are actually AI generated. But overall, we can see that these classifying tools, even though they are necessary, as we see in many cases in academia, school, professional applications as well, it is necessary that we have a way to detect AI generated text, and it's not an ethical issue. It's more of just each entity can say for itself whether they want some level of purely human written content, whether they're okay with a small level of AI written content. That is not the problem, though. The problem, or rather the question that we're attempting to address is, how can we first establish that baseline of whether something is in part or in whole generated by AI? And from that, the specific entities, whether it's a schooling system, whether it's in academia, the journal, they can decide for themselves what they want to do with that information. But first, we want to lay that differentiation where we know that this is AI generated content and this is human generated content. And that can be helpful in building those frameworks when we want. In even journalism and op-eds, many companies are now having quotas. They're saying, if you are using AI generated tools, please let us know. They're not outright restricting it, but they do want to be aware of when it is being used. And that's the main concept that we're trying to get at here. And as we can see clearly, the failures of these AI detection tools is very prevalent, as opposed to the successes, which are not as prevalent. And when we look at certain languages, it can actually put students or professionals at harm when their human written text is incorrectly being marked as AI generated, when it is individual work. At the same time, in English, when there are many tools for AI generated text, excuse me, many of those may actually go undetected. As you can see, this AI text classifier, it does not perform very well on both sides, but specifically I'm speaking about the false negatives. They're very prevalent in English, and that can mean many pieces of text going unnoticed as AI generated when they're just being ranked as human written. And with that, I'd like to turn it over to the session chair and open up for questions. And in further work, I'd like to quickly note that we hope to look at other AI text classifiers, especially this new one that OpenAI is looking to release with audio-visual content. And we'd also like to look at the other services such as Turnitin.com and Grammarly to see if their classifiers are actually working or whether it has the same level of inaccuracy across languages as the OpenAI's open access text classifier does. And with that, I'd like to conclude my presentation.